What's up? I'm Vin, and today I want to go through the January 2024 Algebra 1 Regents, and I'll leave a link to a copy of this test in the description below. Now let's get started. For this video, we're going through all 24 Part 1 questions, and every one of these questions is worth 2 credits. Question 1, we have a graph over here, and it represents a dog walker's speed during a 30-minute walk around the neighborhood. And we have this graph here, we have speed going along the y-axis, and we have time going along the x-axis. And we want to know which statement best describes what the dog walker was doing during the 12 to 18 minute interval of his walk. So if we look over at 12 to 18 minutes, so that's going to be over here in this section here. If we look at this graph, it's very tempting to say that the dog walker is standing still. Question 4 is a very dangerous bear trap, okay? We have to be very careful here and think about what's going on. This y-axis represents the dog walker's speed. So if we look here at about this point here, this is 1.5 miles per hour. So what you should be thinking about is that from 12 to 18 minutes, the dog walker is going 1.5 miles per hour. So let's think about what this means. If the dog walker is walking at a rate of 1.5 miles per hour for this entire stretch here, that means that the dog walker is walking at a constant rate, okay? The dog walker is not speeding up or slowing down here. If we were on a space like this where, let's say, the dog walker was going here with an upward slope, that means the speed is increasing. So then the dog walker would be increasing his speed. If we look at one of the parts of the graph here where the slope is negative, notice here the speed would be decreasing. Okay, so that's how we know it's not 3. And the dog walker would be standing still when the speed is equal to 0 miles per hour. So if we want to see when would choice 4 be correct, that would be somewhere, let's say here, between 8 and 10, where the speed of the dog walker is 0 miles per hour. Okay, so this would be the time where choice 4 is correct, but in this situation here, we're going with choice 1. Question 2, we have this relation, and we want to know which value of x will make this relation a function. So in order for a relation to be a function, we need to have no repeating x values. Okay, so this is something that has to happen here. We have to have no repeating x values. And another way to approach a question like this is to graph all of the points and see that they pass the vertical line test. But for this question, the no repeating x values idea is going to be the easiest approach. Because right now we have x equals 0, x equals 2, x equals 4, and we want to know what's the mystery value of x that can make this work. Well, 0 is out because if we put a 0 here, we would have repeating zeros. If we put x equals 2, that would be bad because we would have an x equals 2 here and an x equals 2 here. And then also x equals 4 would be no good for us. So x equals 6 is going to be the one here, okay? So x equals 6, then we would have all different x values. And now the reason why the vertical line test would also reinforce this idea is if I were to just plot these points that we have so far, we have 0, 4, and I'm not drawing this to scale, this is just to get the idea across. And then we have 2, 6, so let's say this point over here, and then we have 4, 8, okay? So going up to this point over here like this. If I were to plot, let's say, one of the wrong answers, let's say I'm going to say here like, oh, x is equal to 0 again, then 0, 7 would be this point here. But notice that we would have a vertical line. If I do this highlighted here, notice that this vertical line like this would hit these 2 points. Okay, so that's how I know x equals 0 once again is no good, because if I plot 0, 7 and 0, 4, this vertical line would hit 2 of those points. Okay, so that, once again, is no good. Choice 3 is our answer. Question 3, we have a ski rental company, and they charge an insurance fee and an hourly rental rate. And then we have the total cost is modeled by the function r of x equals 30 plus 40x. And then we have, based on this model, which statements are true. So for a question like this, I always think of y equals mx plus b. And with y equals mx plus b word problems, m represents the rate, and b represents the fixed amount. Okay, so that's what I'm looking for in a question like this. I'm asking myself, what's the rate and what's the fixed amount? So when I reread this question here, I look at this part over here. We have an insurance fee and we have an hourly rental rate. So the insurance fee, I know, is going to be the fixed amount. And the reason being the language they use here, that we have an hourly rental rate. So that's going to correspond to the coefficient of x. Okay, so this is the part here that I'm matching up. And notice they gave us r of x. They wrote it a little bit out of place. They wrote 30 plus 40x, but the hourly rental rate here is going to correspond to 40. Okay, so 40 represents the hourly rental rate. So now I'm going to go through these answer choices here. And maybe before I do that, I'll just also note here that the fixed amount here is the insurance fee. Okay, so this is the insurance fee. And now this will give us guidance here as we go through the 4 Roman numerals. We'll make that a little bit neater. Okay, so the insurance fee. Now, R of X represents the total cost. That's definitely true because we have the insurance fee plus the amount of money that we are paying for renting the skis for X hours. Okay, so this part here, this is the insurance fee, and then this part here represents the rate, the hourly rental rate over here. So that makes up the total cost. So Roman numeral 1 is definitely true. Okay, this one is good because we would add the insurance fee plus however much we're going to pay for renting for X hours. X is the number of hours rented. That is definitely true. Okay, so they told us here the total cost is modeled by the function R of X. And the key part here that X is the number of hours is because the rate is the hourly rental rate. Okay, so the fact that they told us this is an hourly rental rate tells us that if we multiply 40 by, let's say, X equals 3, that would tell us how much we're paying for 3 hours. So that's how we know X is going to be in hours. And then next we have $40 is the insurance fee. That is not true. Okay, $40 is not the insurance fee because the insurance fee is the fixed amount. That's the plus 30 over here. And then we have 30 is the hourly rental rate. That is also not true because once again, 30 is the insurance fee. 40 would be the hourly rental rate. So if we switch these two, if we wrote 30 over here, so if we wrote 30 and then 40, then this would all be correct. Okay, but that's not the case here. We're going with choice 2. 1 and 2 are the only true statements here. Question 4, we're looking for the 11th term of the sequence given here. And for a question like this, I'll pretend that we don't know any special formulas for this. So for this one, we'll just say our first term is equal to 3. And then what we want to do is we want to find a pattern. How are we getting from one term to the next? Well, to get from one term to the next, we're multiplying by -2. So to find my second term, I'm taking 3 and I'm multiplying by -2. And that gives me -6. So if I repeat this idea, let's say I multiply this by -2. That's going to give me positive 12. But I'm going to do it a little bit different. I'm going to write 3 times -2 times -2. And that gives me 3 times -2 squared. And this is going to give us, we're going to have a sub 3 is equal to positive 12. Okay, which you could even see, -2 squared is 4, and 4 times 3 is 12. So the pattern, what I want to look for here is if my third term is 3 times -2 to the second, and my second term is 3 times -2, I'll write the exponent in, 3 times -2 to the first, what is the relationship between the power of -2 and the subscript, or the number of terms that we're up to? So notice here, for my second term, it's -2 to the first. For my third term, it's -2 to the second. So by the time I get to the 11th term here, I'm going to skip all this stuff. I'm going to have 3 times -2 to the power 10, okay? Because once again, the relationship between the term that we're up to and the power that we have at the end is that it's 1 less. So now we'll just type this in. We have 3 times -2 to the power 10. And notice that we're going to get here 3072. Now, one thing to be very careful with, please don't do something like this. Don't do 3 times -2 to the 10th like this, because the calculator is going to read this as 3 times -1 times 2 to the 10th power, and it's going to give you choice 1. But choice 1 is a very dangerous bear trap, okay? So just be on the lookout for that. Another thing here too is if you wanted to, you could do this by brute force. You could start at your 4th term and you could multiply by -2 a few more times until you get to 3072, because going from the 4th term to the 11th term, that's only like a jump of 7, okay? So that's not a lot that we would have to do. It's not like we're looking for the 100th term. So that also is an option. And remember, you get 3 hours for this region, so if you want to spend the time to make sure your answer is definitely good, you can. But if we do this the way where we're looking for patterns so that we save time, we're going to use this method over here, and our correct answer is 3072. So the 11th term is 3072, and this is going to match up with choice 3. Question 5, which of these represents exponential growth? So for a question like this, let's just go through the answer choices one by one. Aiden adds $10 to a jar each week. This is not exponential growth. This is linear growth. Linear is when you have a constant rate of change. So what I'm thinking about for Aiden's situation here is that we're starting with, let's say, $10, and then we just keep adding 10 to the jar. You can notice that to get from one term to the next, we're just adding the same thing each time. So that's how we know this is linear growth. We have a constant rate of change. To get from one value to the next, we're just adding the same thing. We're adding 10 each time. 2 is also no good. A pine tree grows 1.5 feet per year. So let's say that this pine tree starts, I don't know, let's say it's 15 feet high. And then it grows 1.5. That would be plus 1.5 would give us 16.5. Plus another 1.5 would give us 18. And then we would be at 19.5 and so on. This is also linear growth because we have a constant rate of change. The tree is growing the same amount each year. And then we have Ella earns $20 per hour babysitting. This is also linear growth, okay, because the rate of change is constant. So Ella works for 1 hour and she has $20. 2 hours is $40 and then 60 and then 80 and so on. Okay, but notice that each value here from one to the next, to get from one to the next, we're just adding 20 each time. So just by process of elimination, it has to be 4. But let's see why 4 is definitely good. We have the number of people majoring in computer science doubles every 5 years. Okay, well, let's say we're starting here with, let's say there's 20 computer science majors at a college. That's a very low number, but we'll just go with the question. So 5 years later, now there's 40. And then another 5 years goes by, we double this again, and we get 80 this time. And then we double this, and we get 160, we get 320, and so on. So notice that to get from this value to this value is a difference of 20. We'll just make that a little bit neater. So the difference here is 20, but then the difference from here to here is 40, and then the difference from here to here is 80. So you could see that the rate of change is not constant in this case here, okay? And doubling means that if we're multiplying by the same thing each time, that is exponential growth, okay? So that is, once again, one type of growth. It's different from linear growth, but exponential growth is when you multiply by the same value each time to get from one value to the next. So choice 4 is definitely our answer. Question 6, my best advice is to line up the like terms. The same way back in the day when you did something like, let's say, 987 minus 654. When you did this subtraction, this would make your elementary school teacher cringe if you were to write it like this. What you should do is line up your like terms like this, and then you could just go ahead and subtract. You could go 7 minus 4 is 3, 8 minus 5 is 3, 9 minus 6 is also 3. And it's the same idea for algebra. So what I'm going to do is I'm going to write this one first. I'm writing negative x squared plus 3x and then minus 7. And what we're doing is we're subtracting. So we have to be very, very, very careful here. Please make sure that you send the minus all the way through like this. And what that's going to do is it's going to change the sign of everything on the inside. So we're going to have a minus 4x squared. We're going to have a minus 5x. And now this last one here, minus 2, is going to change to positive 2. So when I do the polynomial addition or subtraction, I like to line up my like terms. So now I could say negative x squared minus 4x squared is minus 5x squared. One thing I do want to point out is we don't have to go right to left like we do when we're subtracting numbers, because in a case like this, we might have to worry about borrowing or something. But just know in algebra, you're only allowed to combine like terms. So here I could only subtract the x value, the x squared values. I could only subtract or add the x values here, and then I could only add or subtract the constant values. Okay, so just know with polynomials, you could kind of bend the rules a little bit, but the idea is the same as elementary school. So now you have 3x plus negative 5x, or 3x minus 5x is negative 2x. And the math that I'm doing in my head is I'm doing 3 minus 5 is negative 2, and then I just carry down the x. And then I have negative 7 plus 2, that is negative 5. Okay, so now from here, I just scan the answer choices. We have negative 5x squared minus 2x minus 5, and this is going to match up with choice 2. Now, let's say we just want to use the calculator to get our answer. we could go over to the y equals and we could copy down the expression at the beginning of the question. So I have parentheses, negative x squared. So I'm going to write minus and then x to the second power. And then we have plus 3x and we have minus 7. I close the parentheses and then I write minus and then I open the parentheses and I have 4x squared. I have plus 5x. And then last I have minus 2 and I close the parentheses. So now right under this, I'm going to write the correct answer. We have negative 5x squared minus 2x and then minus 5. If I did this right, the blue and the red graph should completely overlap when I press graph. So notice these graphs completely overlap. And if I press second graph to go to the table, notice that my y columns do match. If I were to write the wrong answer in, let's say I had gotten instead choice 1. Let's say I messed something up. All I'd have to do here is just change this to a minus 9. But notice now when I press graph that these graphs don't overlap. And if I press second graph and go to the table, my y values don't match anymore. Okay, so then I would say, oh, choice 1 is not correct because the graphs don't overlap and their y values are not matching for every x value. Okay, so that's one way of doing this with the calculator. But either way, we're going to get choice 2. Question 7, we have f of x equals x squared. And then we have which function is the result of shifting f of x 3 units left and 2 units down. So for this question, if you know the rules for transformations, you'll know that to move something left or right, you have to replace x with the opposite of the direction you want to go. So if I want to go 3 units left, I'm going to write x plus 3, okay? And if I had more x's in my function, I would have to do that to every x that shows up, all right? So then next, we want to go 2 units down. Now, sadly here, this is not an opposite relationship. When you're going up or down, you are going to match the direction you're going. So 2 units down, we're going to write minus 2. And now just looking at the answer choices here, I could see that j of x is going to be our function. Okay, so choice 3 is our answer. But for a question like this, the calculator would be very good to use. So we would have f of x equals x squared. And now I'm going to write in the correct answer. We have x plus 3 squared. So you have x plus 3 in parentheses, and then we square it. And I'm going to tack on minus 2. And if we did this right, we should be moving 3 units left and 2 units down. So our vertex should be in quadrant 3, which it is. Notice that the blue goes 1, 2, 3 to the left and 2 units down. So the calculator, once again, can save the day, but it does help to show up to your Algebra 1 Regents knowing your formulas. But in either case here, we're going to get choice 3. Question 8, we have an equation to find the velocity of an object. And here's the equation over here. And that's a physics equation. U represents the initial velocity, V represents the final velocity, and then we have A is the acceleration of the object, S is the distance traveled. When this equation is solved for A, the result is, so our goal here is to start with this equation and solve it for A. So we have V squared equals, and then we have U squared plus 2AS. So our goal is to solve for A. All right, that's what we want to get by itself. So I would move this over first. I would do minus u squared on both sides. So minus u squared. And for these type of questions, this is called literal equations. The challenge is that things cancel out on one side, but then the variable is still there on the other side. So everything that was there in the beginning is still going to sort of be there in the end. So we're going to have on the left v squared minus u squared. And now on the right side, all we have left is 2as. All right, but this is 2 times a times s. And our goal, once again, is to solve for a. So if I want to get a by itself, I'm going to divide by the two things that are being multiplied to a. So I'm going to divide by 2, and I'm going to divide by s. So divide by 2s on both sides. And now a is by itself. We could say that a is equal to, we have v squared minus u squared over 2 times s. And now we just scan the answer choices here, and this is going to match up with choice 2. Question 9, we have Mrs. Smith's math class surveyed students to determine their favorite flavors of soft ice cream. And here are the results in this table here. Of the students who preferred chocolate, approximately what percentage were seniors? So with this condition here that we're only looking at the students who preferred chocolate, that tells us we're only going to focus on this column here. Okay, so this is where we're shifting our focus. And we want to know, out of these people, what percent were seniors? Well, we can find the total here. If we add the numbers of juniors and seniors in this column, we have 2 plus 7 is 9. and we have 4 plus 6 is 10. Okay, so there are 109 people that like chocolate amongst the juniors and seniors that were surveyed. So now what we have is, if we're looking for the percent that were seniors, we're going to do 67, okay, because there are 67 seniors if we're focusing on this column here. And we're going to divide that by the total number of people that preferred chocolate, which was 109. Okay, so now we just have to divide these two. So we'll do 67 divided by 109, and this tells us our percent here. And notice that we get everything here as just a decimal. We have 0.61 whatever. So to convert this decimal to a percent, we could just multiply by 100. So times 100, and now this will help us find our answer. So for this question here, we're going with choice 4. Now, one thing I do want to point out, let's say there were other answers that are closer to this answer. Here, it looked like every single answer choice that the answers were rounded to the nearest tenth of a percent. So if I look here at the tenths place is a 4, and then I look to the right is a 6, that would tell us to round this up to 61.5% like this. Okay, so that's how I know for sure choice 4 is our answer. Now, once again, this was the only answer that was reasonably close to this. But if we did have to round here, once again, we look to the right, and if it's a 5 or higher, we round up. If it's a 4, 3, 2, 1, or 0, we round down. So in this case here, we're going with choice 4. Question 10, we have f of x and g of x, and we want to know what is the value of f of 1 minus g of 3. So for this one here, what we could do is we could plug in 1 to f of x and find out what is the function value here. So I replace all of these x's with the 1, and then I just evaluate this. So I have 1 squared plus 2 times x is equal to 1, and then plus 1. So here I'm just doing 1 plus 2 plus 1, and that's equal to 4. Okay, so this we could just simplify by hand. And then g of 3, I could find by plugging in x equals 3 to this function here. So I have g of 3 equals 3 times 3, and then plus 5 at the end. So this would give me 9 plus 5, which is equal to 14. So if I want to know the value of f of 1 minus g of 3, I would just plug in here now. F of 1 equals 4 minus g of 3 equals 14. And 4 minus 14 is negative 10. And this will match up with choice 3. If you want to do this question with the calculator, just go to the y equals, and you could type in x squared plus 2x plus 1. And then underneath here, we're going to write in g of x is 3x plus 5. And I'll show you a cool trick. Notice that f of x we wrote in the y1 spot, and g of x we wrote in the y2 spot. If you have a TI-84 plus CE, you could press alpha trace y1. And remember, y1 was f of x. And you could input the value like you would function notation. So I could say, remember, y1 is f of x. So I could say y1 of, I put a parenthesis here, and then I put 1 and I close the parentheses. So this, the calculator will read as f of 1. And then I could just write minus g of 3. Remember, we saved g of x in the y2 spot. And if you have a slightly older calculator and you don't have that alpha trace option, you could always press vars, go to the right, and then go to function and get y2 directly from this screen over here, okay? And then I'm doing g of 3, so I put a parenthesis, a 3, and then I close. And then notice this is going to give me negative 10 all at once. All right, so that is one option. Or you could just press second graph, and you could go to the table here and see that f of 1 was equal to 4, and g of 3 is equal to 14, and 4 minus 14 is also negative 10. But I just think this is a cool trick to have. This is a pretty helpful trick, not just for Algebra 1, but for future levels of math. But for this question here, we're going to get choice 3. Question 11, we want to know which function has the largest y-intercept. So you should know that the y-intercept is where the graph crosses the y-axis. Okay, so what I'm imagining is I just think of any graph here of any function, and the y-intercept is the value where the graph hits the y-axis. Okay, so that's what comes to mind at first. But if I have an equation or a function, I could find the y-intercept by plugging in. So I would plug in x equals 0. Okay, because notice that wherever the y-intercept is, let's say this one here was, let's say 0, 5, okay, or it hits the y-axis at 5. Every y-intercept you could think of, what they all have in common is that the x value there is equal to 0. Okay, so you have to know how to find a y-intercept in multiple forms when you have a graph, a table of values, or when you have functions. So for something like choice 1, I would just plug in x equals 0. So f of 0, if I plug in, I have negative 4 times 0 and then minus 1. And that would give me 0 minus 1 is negative 1. And then let's say I look at choice 2 next. When x is equal to 0, my y value is equal to 2. And I want to find the largest y-intercept. So right now I have a y-intercept of negative 1. So this y-intercept of 2 over here, so we're comparing negative 1 to positive 2. Positive 2 already wins, so choice 1 is out. And now I look at choice 3. If I plug in 0 over here, so g of 0 equals the absolute value of 0 and then plus 3. And 0 plus 3 is going to give us 3. So now 3 beats 2. Okay, so now we have a new winner here. So this y-intercept is winning right now. So choice 2 is out. And now I look at choice 4 and notice it's in the form of a graph here. And the graph hits the y-axis over here. And this is the point 0, 1. So our y-intercept here is equal to 1, which does not beat 3. We're looking for the largest y-intercept. So choice 4 is out and choice 3 is definitely our answer. Question 12, we have this linear inequality word problem, and it's the same idea as before when we were dealing with the linear equation word problem. When we had y equals mx plus b, m represented the rate of change. Okay, so this was the rate that we started with, and b represents the fixed amount. Okay, so that idea is not changing at all. So when I do these questions, I'm looking for which part depends on x, which part changes at a specific rate, and which part is like the one-time fee. So if we're looking at plan A versus plan B, I'm just going to build up each of these linear expressions based on the information in the question. So we have plan A has a monthly fee of $15 with a charge of 8 cents per text. Okay, so the word per gives away that 8 cents represents the rate. Okay, so this is the $1 million phrase right here. 8 cents per text. This word specifically tells me that this part over here represents the rate. Okay, and then they tell us the monthly fee, that's the fixed amount. That doesn't depend on how many texts we send. That's just how much they're going to charge us. So this is the fixed amount. This is our B value. So when I have to write out some linear expression for plan A, I'm just using these values now. The rate is, we have 0.08. And now just looking at the answer choices, they're not using X, they're using T. They're telling us T represents the number of text messages in a month. Okay, so I'm going to say 0.08 times T, and then plus, it's a $15 monthly fee. And then next we have for plan B, there is a monthly fee of $3 with a charge of 12 cents per text. Okay, so for this one, this part here represents the rate, the 12 cents. And then we have a monthly fee of $3. This is also the fixed amount. Okay, so when we have to build up the expression for plan B, those are the numbers we're going to be using here. So the rate here is going to go in front of not X, we're going to use T instead. So we're going to have 0.12 times T, and then plus the fixed amount is, we're going to have plus 3. But now we just have to read very carefully here, because notice 15 plus 0.08 times T, and then we have 0.12 T plus 3. This is matching up with the first two answer choices. Notice over here that everything got mixed up. These answer choices mix up the rate and the fixed amount. But now we just read very, very carefully. So which inequality should be used to show that the cost of plan A is less than the cost of plan B? So we want the cost of plan A to be less, so I'm going to put a less than sign, than the cost of plan B. So now when we look at the answer choices, we're going to see that this matches up with choice 1. Question 13, we have the function f of x is graphed on the set of axes below, and we want to know what is the equation of the axis of symmetry for f of x. So for this question here, we're looking for the axis of symmetry, which is the line that cuts this parabola in half in such a way that if we were to fold the parabola over this axis here, this would be a perfect line of symmetry. This part of the graph would fold over onto this one, and also vice versa. If I fold the graph over this way, it's going to fall on top. So now we just have to come up with an equation for this line. And notice that this line hits the x-axis at x equals -1. So the actual equation for this line is going to be x equals -1. And I can see right away choice 1 is our answer. But there is one answer choice that we have to explore. Just be very careful not to choose choice 3. Choice 3 is a very dangerous bear trap. For this one, students look at this and say, oh, the y-axis is vertical, so I bet it's y equals -1 instead. But you could even see here, if I go to the y equals, and I just graph the line y equals -1, so I write y equals -1, and I press graph, notice that this would give me a horizontal line going through -1, okay? So that's how I know that choice 3 is no good. Now, one more thing before we move on. If I were to take a few random points here, let's say I take these 3 points. One thing all of these points have in common, so this is -1, 1. This point up here is -1, and we have 2, 3, 4. So this is -1, 4. And then this last point here, we have -1 and then -4. Okay, so this is, once again, going to the left 1 and then down 4 like this. And one thing to pay attention to is notice that all of these points, what they all have in common is that their x-coordinate is equal to -1. So that's why the equation looks like this. That's why the equation is in the form of x equals a constant. But otherwise, if you do forget, remember, you can just use the calculator to verify. But for this question, we're going to go with choice 1. Question 14 is so easy, it's difficult. You just have to know the vocabulary here. The degree of a polynomial is the highest power of x that appears in the polynomial. So notice here that we have x to the power 3. It is all the way at the end. So the degree of our polynomial here is going to be 3 because, once again, that is the highest power of x that appears. The most common mistake here, though, is people think the degree, and they just look to the front here and they say, oh, 5 is in the front, so they choose choice 5. And they say, oh, x to the first, that's the first power of x that appears, so they choose choice 1. But just be very careful here. Remember, the degree of a polynomial is the highest power of x that appears in the entire polynomial. If you want, you can take the time to write this in standard form. So I write this in descending power order like this, and then it's more obvious here that our degree is the highest power of x that appears, and it's the first one that appears here, x to the third. So you don't have to rearrange this, just go on a scavenger hunt and find the highest power of x. In this case, the power is 3. That's our highest power, so choice 3 is our answer. Question 15, we want to find the product of these two polynomials here. And what I'm going to do is I'm just going to write the times here, and I'm going to align these vertically. So I'm going to distribute term by term here. I'm going to do x squared times x, that is x to the third. And then I have x squared times -3 is -3x squared. And then I'm going to write underneath this, I'm going to do 3x times x is positive 3x squared. And notice I'm not writing this in a single row. I'm lining up the like terms. And then I have 3x times -3 is -9x. Okay, and then last I distribute 9, and I have 9 times x is 9x. And then finally I have 9 times -3 is -27. And notice what happens here. We have -3x squared plus 3x squared. These cancel. Then I have -9x plus 9x, which also cancels because these are matching opposites. And all I have left is x to the third is my first term here, and then I have -27 at the end. So this simplifies to choice 1. We have x to the third -27. Question 16, we want to solve this equation here, and there's a few ways we could do this, but one way to do this would be to multiply both sides by the least common denominator. And the reason why I like to show this method is because it gets rid of all of the fractions that you have in your equation. And I find that students, when they can get rid of fractions, they prefer to, because it makes solving the equation just a bit easier. So here, the two denominators we're looking at are 3 and 4. And if we think of the multiples of both of those numbers, the first place that these multiples match up is at 12. Okay, so if I list the multiples of 4 and 3, notice that the first place that these multiples match up is at 12. Okay, so that's going to be our least common denominator. So what we're going to do is we have this equation here, and we're going to multiply both sides by 12. Okay, so let's just start off this way. So we have times 12 on both sides. So we have times 12 on the left, and we're going to have times 12 on the right. Now on the left side, we could do 12 divided by 3 is 4, and then 4 times 2 is 8. So now we have 8 times 3 minus 2x equals, and 12 divided by 4 is 3, and 3 times 3 is 9. So now we're solving this equation, which is definitely a bit easier to work with. So I'm going to distribute here. We're going to have times 8 going through, and that's going to give us 24 minus 16x equals, and on the right side we have 9. So now to solve for x, we could just subtract 24 on both sides. And now simplify here. So on the left, 24 minus 24 cancels. On the right side, we're going to have 9 minus 24 is negative 15. And on the left side, all we're left with is negative 16x. So now we divide both sides by negative 16. And on the left side, negative 16 over negative 16 cancels. And we have x equals a negative over negative goes positive. So we have 15 over 16. And this matches up here with choice 4. But if you have a calculator, you could use this really awesome trick. So you could go math, you press up, and you go to numeric solver here at option C. And what you do is on the left side here, we're going to write this left side in equation 1. So I have the fraction 2/3. I'm going to press alpha y equals enter to pull up a blank fraction, and I have 2 over 3. And then I go to the right to get out of this, and then I have in parentheses 3 minus 2x. And then for equation 2, that's going to be the right side, 3 over 4. So I have alpha y equals enter, and I have 3 over 4. Just know that I could just do 3 divided by 4 like this, but I just think using the alpha y equals enter feature just makes this look much nicer. All right, and now to press OK, I'm going to press graph, and I'll press solve by pressing graph, and I get this value here. So I get 0.9375, like a million zeros and a 2. So I'm really just going with 0.9375. So if I go back to the main screen, 0.9375, I press enter, and then I'll press math, enter, enter. And notice it gives me 15 over 16, which matches exactly what we have here. Okay, so that's just a nice trick that you could use to solve these. But this is the algebra, Regents. So I would recommend, learn how to solve these equations because it is algebra. But if you really need to, you could absolutely use this trick. This calculator is allowed, and it will get you to choice 4. Question 17, if f of x and g of x are graphed on the same coordinate plane, for which value of x is f of x equal to g of x? So for this question, we could just go to the y equals here, and we're going to write in for f of x, we have 2x plus 6. And then for g of x, we have absolute value x. So we press math, we go to the right here, and then absolute value x is option 1. And then I'm just going to write in an x inside the absolute value bars here. And now I press graph. And if I want to know where are these two functions equal for which value of x, I can just see right away it's at x equals negative 2. But let's say it was some decimal value. I would press second trace number 5 for intersection. I just have to get really close to the intersection point here. And then I press enter 3 times. And that tells me the intersection is at negative 2, 2. So using the calculator, we could see that when x is equal to negative 2, these two functions are equal. Question 18, we want to find the solution to this inequality here. So we're starting off, I'm just going to rewrite it over here. We have 2x minus 7 is greater than, we have 2.5x, and then we have plus 3. So for this, I'm going to move the x terms to the left side. So I'm going to do minus 2.5x on both sides. Okay, so we're doing minus 2.5x on both sides. And now what I have here, after this cancels, I'm doing 2 minus 2.5. And that's negative 0.5, and then I just tack on the x. And then I have minus 7, and then I just bring down my greater than sign here. I have greater than 3. And now I'm going to just add 7 to both sides to get the x term. Our goal is to get the x term by itself. So that's why I'm going to do plus 7 at this step. And now negative 7 plus 7 cancels, and we have negative 0.5 times x is greater than 10. So now we divide both sides by negative 0.5. But there's one really big idea you need to know with inequalities. When you multiply or divide both sides by a negative, the inequality flips. Okay, and now I could say 10 divided by negative 0.5 is equal to negative 20. All right, the math that I'm doing in my head, I'm doing 10 divided by negative 1/2. And then I'm using keep, change, flip. I keep the numerator, I change the operation to multiplication, and then I flip the fraction on bottom. So I have 2 over negative 1. And then if I work this out, this is 10 times 2 is 20 divided by negative 1, and that equals negative 20. Okay, so that's the math you could do by hand, or you could just do 10 divided by negative 0.5 in the calculator. But now we just look here, and this is going to match up with choice 4. Question 19, we have these 3 expressions here, and we want to know which of these expressions are equivalent to 8x to the third y to the 6th. So for this question, it helps to know these 3 rules for exponents. So first we have a to the b times a to the c is equal to a to the b plus c. So when we multiply exponents with the same base, we just add the exponents together. When we have a to the b to the c power, so a power to a power, we multiply, and we would have a to the b times c. And then next, when we have a product being raised to the same power, we would have, in this case here, a to the c times b to the c. So all we have to do for a, b, and c is apply one or more of these 3 rules and see which ones match this. So what I'm seeing here is we have a product of 3 terms to the power 3. So I could rewrite this as 2 to the third times x to the third, and then I have times y squared to the third power. And we'll just make space here. We'll just get rid of this work from before. So we'll just get this out of the way so that we have space to work this out. So let's see, what does this work out to? So this is going to be 2 times 2 times 2 is 8. Then I have x to the third, and then y squared to the third is going to be this second rule over here. So I multiply 2 times 3 is 6, so I have y to the 6th power. And notice that this matches what we have over here, 8x to the third y to the 6th. So a is good. Okay, this one is equivalent to what we have here. And now for b, I would do 2 to the third. So you see I have a product to the third, so I'm using this third rule. So I have 2 to the third times x to the third, and then I have just y to the 6th. And 2 to the third power is still 8. So you have 8x to the third, and then y to the 6th. So this one also works. And now I have 2 times 4 is equal to 8. So I'm multiplying these 2 numbers together, 2 times 4. And then I have x squared times x to the invisible power 1. So now I'm using that first rule. So I have x to the second times x to the first. I would do x to the 2 plus 1 power, which is going to give us x to the third. And then I have y squared over here times y to the third power. So here, notice I would do y to the 2 plus 3. Okay, see, I'm adding these 2 powers together. I'm using this first rule again, and that would give me y to the 5th. All right, so this one doesn't match. So C is out. It's going to be A and B only. Choice 1 is our answer. Question 20, we have Joe deposits $4,000 into a CD at his local bank. And just know that a CD is a type of account. And this CD earns 3% interest compounded annually. And then we have the value of the CD in X years can be found using the function. And we have to choose from one of these. So for this question, it really helps knowing the formula A equals P times 1 plus or minus R to the power T. But in this situation here, we're dealing with a bank, and Joe is depositing his money into a bank in a CD account, and the money is growing, okay? So we're going to go with the plus. So when we have to decide plus or minus, plus is when the amount is growing. So in this case, we're going plus. If we had a car depreciating in value, going down in value, then we would say 1 minus R. But in this case here, the bank, his money is growing, so 1 plus. P represents the principal value. That's the initial value that Joe is depositing. So 4,000 is going to be the value here for P. And then next, R is the interest rate. So we have 3% interest here. And 3% as a fraction is 3 out of 100. Okay, remember, percent means out of 100. And now if you just type this into a calculator or just convert it to a decimal yourself, this is 3/100ths. So this is 0.03. All right, just don't fall in the trap of saying 30%. Okay, 30% is 30 out of 100. And this simplifies, if I just cross off these zeros here, to 3/10ths, which would be 0.3. Right, so I could see right away, like these answer choices here, they're just trying to trick you. Okay, so we're dealing with 3%, not 30%. So now the next thing we could say here is we could, say what our function is. The only difference is we're not using t, we're going to use x. So I'm going to say, all right, f of x equals, and now I just plug in. I have p is 4,000. Then I have 1 plus r is 0.03. and we're raising it up to the power x. So now this just simplifies to 4,000. 1 plus 0.03 is 1.03, and now this is going to the x power. And you can see this is going to match up with choice 4. Question 21, we're going to factor completely. And notice for this polynomial that all of the terms have an x, and the leading term has a minus in front. So let's take out a minus x first. But also notice that all of the answer choices start with minus x. So sometimes your answer choices give away what you have to do first. So now we just have to write the leftovers inside parentheses. And a nice trick I like to use for students that struggle with writing the leftovers is I show that you should think about dividing each term by the factor in front. So I have minus x to the third plus 10x squared plus 24x. Okay, that's what I'm starting with. And I'm dividing each of these terms by minus x. All right, that's the math that I'm doing in my head when I write the leftovers inside the parentheses. So I have a negative over a negative goes positive. So I have x to the power, and then I'm using this law of exponents. A to the b divided by a to the c is a to the b minus c. So I'm doing to the power 3 minus the invisible 1. So 3 minus 1 is 2. So I have an x squared at the beginning here. And then I have a positive divided by a negative is negative. And then I have 10x to the power, the invisible 1 here allows me to do 2 minus 1 is x to the first. But I don't actually have to write x to the first. And then over here, x over x cancels. And I have 24 divided by negative 1 is negative 24. So with factor completely, just know that means that you have to keep factoring until you can't factor anymore. So I have to break down this quadratic here. So notice I have a 1x squared in front. So that means I could use this trick. I'm going to look for two numbers that have a sum of negative 10, and the two numbers also have to have a product of negative 24. Okay, and that's part of the reason why we had to divide by negative x, because we want that positive 1x squared so we could use this factoring trick, okay, or factoring technique. So now I have minus x. This is just carrying on, and then I have two parentheses here like this. All right, and then this part of the expression, so the x squared minus 10x minus 24, that's the part that we're factoring over here. The negative x, once again, is just tagging along. So now we have to think what two numbers have a product of negative 24 and a sum of negative 10. The two numbers are going to be negative 12 and 2, because negative 12 plus 2 is negative 10, and then negative 12 times 2 is negative 24. Now, some people might choose something like, let's say, negative 6, negative 4. Okay, they're looking at, let's say, this answer choice over here. But negative 6 plus negative 4 is negative 10, but the product of these two is positive 24. So that's why this pair is no good, and this pair is the one we want. So now I write x minus 12 and then x plus 2. And if I scan the answer choices here, we're looking for, we have negative x times x minus 12, x plus 2 is matching up with choice 3. Now, one thing we could do is the same trick as before. We're going to write negative x to the third, and we're going to write plus 10x squared. And then we have, at the end, plus 24x. And we could just write all of the answer choices in the y2, y3, y4, y5 spot. But let's pretend that, we checked them all, but now we got to choice 3. So we're just going to verify that our answer is good. So I have negative x, parentheses, x plus 2. I close the parentheses, I open one more, and I have x minus 12. And now I close this and I graph, and notice that the graphs completely overlap. If I press second graph and go to the table, all of the y values match. So choice 3 is definitely our answer. Question 22, when temperature is 59 degrees Fahrenheit, the speed of sound at sea level is 1,225 kilometers per hour. Which process could be used to convert this speed into feet per second? So for questions like this, let me start off with something easy. I am 6 feet tall, and let's say I want to find my height in inches. Well, I know that 1 foot is equal to 12 inches. So what I'm going to do is I'm not going to multiply this by 12. I'm going to multiply this by 12 inches over 1 foot. And what I'm basically doing here is I'm multiplying by a fraction that is equal to 1. Because when you have equal quantities in the numerator and denominator of your fraction, they simplify to 1. So I'm really multiplying 6 feet by 1, but in a creative way such that it will change the representation here. So what I have is feet over feet, the units cancel, And then I do 6 times 12 is 72, and the only unit left is inches. Okay, so this conversion factor allows me to convert feet to inches. But in this situation here, we have 1, 2, 3, 4 conversion factors. All right, so this is more complicated, but the big idea that we're transferring from this is we want the units to cancel. And the only way units cancel is when you have a unit in the numerator and a matching unit in the denominator. Okay, so that's what I'm looking for. They all start off the same. They're all starting 1225 kilometers per hour, but we just have to make sure that the units cancel. So let's say choice 1. Notice we're converting or using this conversion factor. Kilometers over kilometers cancels. But then notice here that by the time I get to this part, like yes, hours over hours cancels. However, at this step, I'm doing miles times miles, which would give me square miles at the end. Okay, and this is not what I want. I want feet per second. So choice 1 is no good because the units are not canceling out in such a way that we are ending with this. Okay, so remember, we're starting with kilometers per hour. Our goal is to end. Okay, what we want is we want to end with feet per second. Okay, so 1 is out. And now looking at this one, kilometers over kilometers cancels, miles over miles cancels, and then we have minute over minute cancels. And let's see, do we have hour over hour canceling? We do. We have hour over here canceling with hour over here. And notice what's left. The unit on top is feet, and the unit on bottom that we're left with is seconds. So this one is good, but just to be safe, I'm going to check the other answer choices and show why they're no good. Well, right away, I could see we're doing kilometers times kilometers, which is square kilometers. Okay, and there's no more kilometers on bottom to cancel out square kilometers, so 3 is no good. And then here, kilometers over kilometers cancels. We have, let's see, any matches here? Notice minute times minute would give us square minutes. All right, and our goal is to have seconds in the denominator. There's no more square minutes on bottom to cancel this out, so that's how I know 4 is no good. 2 is definitely our answer. Question 23, we have the zeros of a polynomial function are -2, 4, and 0. And we want to know what are all the factors of this function. So for this question, the big idea is that factors and roots have an opposite relationship. So when I look at these roots over here, the factor that we're going to have from a root of x equals -2 would be the factor x plus 2. Okay, so the opposite of -2 is +2. So this would be the factor coming from this root here. And then if I have a root of x equals +4, the factor would be x minus 4. Okay, and then last we have x equals 0. Now 0 is neither positive nor negative. So technically you could say x plus 0 or x minus 0, but x plus or minus 0 is just going to give you x anyway. Okay, so just once again, x plus or minus 0, it doesn't matter which one you go with, is still just going to give you x. So that's how I know the factor from a root of 0 is just going to be x. All right, and then from here, if we just look at the answer choices, we could see that this is going to match up with choice 3. Now, if this is not convincing, what you could do is you could set this equal to 0, and you could pretend that you're solving this all the way through. So I would set each factor equal to 0 like this. And notice if I set each factor equal to 0 and solve, well, the first equation is already solved, but all the others here I would solve by just moving the constant to the other side. So I would do -2 on both sides, and this would give us x equals -2. And if I solve this equation for x, I do +4 on both sides, and that would give me x equals +4. Okay, and this is after all these terms here just cancel out. And notice that I would have the roots x equals 0, x equals +4, and x equals -2. Okay, so choice 3 is definitely our answer. Question 24, our last multiple choice question. We want to know what is the range of the function f of x. And just know that the range is the set of all y values for a function. Okay, so what we could do first is use the calculator to get a picture of this. So we'll go over to the y equals and let's type in, we have parentheses x minus 4. We close the parentheses and square it. And then we're just going to tack on that +1. Okay, and we press graph. And notice we have this parabola over here. And since we're looking for the range, a very important value for us to find, or a very important point for us to find, is the vertex. So it looks like the vertex is happening at 4, 1. But if I really want to be sure, I could press second graph and go to the table. And notice that when we have the point 4, 1, the graph starts to turn around this point because look, above and below 1, we have repeating y values. And if I go 2 up, I get a 5. If I go 2 down, I get another 5. So 4, 1 is definitely our vertex. So we're just going to keep that in mind when we analyze this graph. So now let's find the range of this function. And remember from before, we said that the vertex occurs at the point 4, 1. So notice what we have here for this parabola. The vertex is a minimum point. Okay, so this is a minimum. And what this tells us is that all of our y values are going to be greater than or equal to positive 1. Okay, because notice this parabola is increasing. Okay, it's going upwards like this from the vertex. Okay, so let me just draw that a little bit neater. We have this parabola. Once again, it turns at the vertex, but going to the left and right of the vertex, the parabola is only going up. So notice it's only going to reach these y values here. The lowest point on the graph is at the vertex at 4, 1. It is never going to go into this region over here. So the range, I could say the y values are greater than or equal to positive 1. Notice we can say equals to positive 1 because at the vertex when x equals 4, the y value is 1. And then we look here and see this is going to match up with choice 4. Now, the reason why I could say choice 4, you might be thinking, wait, this says y and this says f of x. But remember, function notation, y equals f of x. Okay, so these are interchangeable. So the reason why 3 is no good is because 1 is included. Okay, the vertex is at 4, 1, so 1 is allowed. That is part of the function. So I'm going to put equals to. And then these answer choices are no good because this is using the x value of the vertex. But in either case here, let's say I was finding the domain of this function. The domain of the function, I could say all real numbers with this symbol like this, okay? That R with the 2 lines means all real numbers because there's no restriction on which values of x I could plug into the function here, okay? I could take any number I want and subtract 4 from it and then square it and then add 1 to that number, okay? So there are no restrictions, and you could even see here by these arrows, this graph goes all the way to the left and all the way to the right. So the domain is all real numbers, and choice 4 in this case is our answer.